Welcome to Epic Begins with One Step Forward. I'm your host, Zander, and I am so honored that you're joining me today. I wanted to start off with this thought of the day. When you're asking for help, make sure that you're being specific. Let me know if you need anything. That's not really helpful. And, people want to help, but if you're not specific, they don't know whether they can commit to that. So for example, I asked a friend of mine to review a chapter of my book. Not, hey, will you help me review my book, but a chapter. He was able to say, of course, and he did it, and I got great feedback. Specific requests get specific results. And the fact of the matter is, if we don't ask a specific question, we often won't get what we needed, and perhaps we'll be frustrated. So today, make one clear help request and don't be surprised when you get what you need. Now I wanted to give you an update about one of the guests I had on my podcast quite a while ago. Warren Pearson is actually from South Africa, and I just went with him on a new kind of a safari. Instead of being out in the bush and seeing wild animals and stuff, we went to Japan, and I'll call it a concrete safari. We saw so many interesting things, and I look forward to sharing some of those in the coming episodes. But what's important to know is that even though we weren't out in the bush and there weren't wild animals, there was all kinds of exciting things to see. So much culture, and it was great to be able to share that with Warren. I am excited today to welcome Anthony Anderson to the show to talk about teenagers, game programming, and technology. So, Anthony, welcome. Tell us a little about who you are and what you do.
Thank you, Zander. Anthony Anderson, as you already highlighted, I'm the Game Programming Academy lead over at Clayton Valley Charter High School. And one thing that I like to do is I don't teach programming, I facilitate the learning of students as they create new content. So.
That's interesting. So back in the prior lives, I actually did some software programming. I grew up in school doing things like Turbo Pascal and stuff. So stuff that's way long gone, but anyway. What are you specifically, how are people programming these days? What are they using to program the games and stuff?
Well, nowadays it's a dynamic field. Mm-hmm. So from the days of, I'm going to go all the way back to Fortran myself, QBasic and likes, but now students are programming in some of the similar languages. So like if they're using the Unreal Engine, they're using C++. If
right.
They're using Unity, they're using C#. And so one of the biggest things that we want to do right now is make sure that the students know what they need to know to learn a new language, if one's come up or anything else for that matter, versus they learned just how to do what they're currently doing.
Absolutely. And as is the case, technology, programming languages, there's always the hot new language, be it Python or Java or SOAP or whatever. And I have to say I haven't been around that, so I don't know what some of the more modern ones in. I just named stuff from the mid-90s, early 2000s, but still. Mm-hmm. What are some of the, you said C++ and C#, those have been around for quite a while.
They have, in fact.
And they are great languages, very powerful.
Mm-hmm. Well, some of them, again, Python, as you mentioned right now, and now moving into things like the Omniverse or different programs that are actually provided by large developers. Mm-hmm. It's moving away from the hard coding languages completely. In fact, working with some partners, they're actually doing visual learning models, or basically just being able to talk to the computer rather than the line coding that we've been accustomed to.
Definitely. And are those new languages, are they compiled, or is it's all taking shape behind the scenes and it just kind of happens?
Just kind of happens right now, yeah.
Right.
So the days of waiting for someone to free up the compiler so that you can run your programs
right.
are long gone. So
okay. One thing I spent 5 years working at Intel, and when I was there, I was working with universities to change their computer science curriculum to teach parallel programming. How much parallel programming are your students aware of? Because of course, all computers now have multiple cores or multi-cores, and taking advantage of that is obviously really important, and especially in gaming. It's one of the few places that really knows how to take advantage of the fact that they have 8, 16, 32 cores. And just for a moment, I'll tell the audience, when I talk about a core, I'm talking about a processor. That's the brain, that's how stuff is happening. And in multi-core, especially in gaming, you can use one of those cores just to render the landscape, so the trees and the grass. The other one may be just rendering characters or the atmosphere or sound and stuff. So are they aware of, and are they doing parallel programming?
They are aware of it, but they're not actually doing parallel programming, because what's happening more so than anything is when they utilize the systems, then the systems handle that on the back end. So that may be taking place with the use of more cores, but from the student's perspective,
They
they're
have no
not
idea.
doing anything with the parallel.
Okay.
No, not at all.
Oh, that's good, because when I was teaching it, I learned that parallel programming, although conceptually an easy thing to understand, much harder to actually know how to take advantage of all of those cores. So that's interesting. How much is AI? Because I know I've read, I haven't actually done anything, but you can get some of these AI models to actually write code for you.
So with students right now, we're seeing a lot of that where they're doing the vibe coding, where it can just be that you're indicating your ideas or your outcomes, and then it's providing the actual code for that. And those work really, really well for speeding up the processes, or allowing things to be a little bit more, what can be automated, it's best to go ahead and automate it, right? So it helps in that area. But in terms of the students learning, they're still learning the baseline of the code, what to do, how to make modifications, how to identify where, although AI may have produced it, AI didn't really know how to use it or utilize it or correct it. And so that's one of the key things.
And I was going to ask about the correcting. I know, having done different languages, there were times where I go to compile or say, all right, here's my code, now go ahead and run it. And there were some of the languages that would just tell you that there was a mistake, but it wouldn't tell you what line of your code you forgot to close a parentheses, or you forgot a comma, or some little thing. And others will say, here's exactly in your code. So
yeah, so some of the compilers now, or at least some of the SDKs, would allow. It's almost like writing code, like writing an essay or an email, where Grammarly won't let you, send, because you have all those underlines and everything else. And so it does the exact same thing when you're writing the code. So it will indicate things that are maybe an error message, maybe something that may be conflicting later on in the program.
Right.
Because it's kind of like on demand. It's doing it as you go. So,
got it. And well, it's helpful to know at least what line you need to look at versus you just wrote, 75 lines of code. And then you're like, and there's a mistake somewhere in there.
Yep.
It's kind of like a English teacher going, yeah, the essay is good, but there's a mistake in there. And you're like, where?
Yeah, I think back to your quote of the day, where it actually being specific, right? And that ability to really have the computer indicate specifically where the problem is. And
that's much harder. Again, you're right. You tie it back into that thought of the day about asking for specific help. If there's just, hey, there's a mistake, it can be really frustrating to try and figure out where it is. So that's interesting. What are some of the, because you mentioned Fortran and some of the classic programming languages. For you as a teacher, facilitator of this, what are some of the good things that you see coming out with what the kids are working with today?
So for me, I think I go to the outcomes. I go to the products that the students are able to produce, more so than the languages. And as I talk with different companies on different ed tech or things that they want to, like, hey, your students ought to be using this, or your students ought to be using that, the questions I always have to ask is, well, how is that going to ultimately help the student more so than just the different processes? So what I'm seeing now is students are able to use something like Python to just scratchbook, make the whole thing in a draft format, and then move over to another platform and say, now that I want to deploy this, I'm going to need to learn Java, or JavaScript or anything else for that matter.
Right. Interesting. And what kind of games or programs are the students making?
So right now, one of the things that I always have to differentiate is, although it's the game programming academy, which is more of a hook for the students to want to engage, they really want to focus in on simulation creation or interactive media.
Okay.
And so with that, one of the games that we're working on right now is working with the Contra Costa Transit Authority, and we're making a simulation of deployment for their mobility hubs. And so what that means is you and I might just play the game, classic game, but the meta that is formed with what I chose to do and what you chose to do becomes valuable data for the transit authority to be able to make decisions based off of that feedback. That's a little bit more than a survey, but it was all through gameplay. And so the students are making simulations or projects for organizations and gamifying what they would want to have done or accomplish more so than titles of, just active entertainment.
Got it. So speaking of this specific project with the Contra Costa Transportation Department, how is my playing this game giving real-time data to Contra Costa? Because is it simulating that I'm trying to get through traffic quickly or something, and then they're looking at what choices I made, or?
So with the game specifically, what we did was we tried I say we, but more of the students than myself, with the idea is that you're playing a classic tower defense. Basically, your destination is going to be what you're trying to defend, and what you're defending right now is you're defending cars from coming across to that location. But in parallel with the, I believe it's SB 743, where they're using vehicle miles traveled. I might have the wrong number for the Senate bill number, but using vehicle miles traveled, you can look at the round trip that a car would come from one distance to another and try to reduce that by having someone convert to bus, bicycle, or transportation. So in the game, you're basically trying to convert as many cars as you can to other modes of transportation.
Oh, I get it.
And then if by your choices and what you did was successful in the game and you did well with that, you've indicated that that would probably be one of the best ways to actually mitigate that traffic problem.
I got it. So they're looking at reducing the number of cars, not necessarily looking at where bottlenecks may be and how to alleviate, areas of congestion.
I think it works both ways, actually, because what the students have figured out a way to do is actually use the actual mapping of the city. So using some of the APIs that we use for something like our GPS or anything else, the game takes place on what would be the actual roads. And so if they're having cars come in from, like we're using our school site, so we may have cars coming over Kirker Pass, we may have some coming down Ignacio Valley, it actually would replicate what the traffic pattern would be, and then whatever the efforts are, if it reduced it in gameplay or in simulation, that would still be what would be proposed as a possible change. Let the engineers do the engineering thing on the back end, but it may actually address the bottlenecking or the highway congestion.
Well, that's really cool, Anthony. That, like, to think that I could go, oh wow, look at this cool game. Let me see how quickly I can get to Clayton from Walnut Creek. And in doing that, I'm actually really helping everyone to figure out what might be the right way to do it. That's really fascinating.
The most powerful tool with what the students are doing is it allows you to capture the actual thoughts of the user in terms of what you would suggest for something, more so than any organization having to ask every single user.
Right. Or, as is the case sometimes, trying to guess how people want to do something, and get perhaps semi-real user data. Right?
Yeah. So if you put a traffic light in and you only have the opinion of those that were vocal, at the council meeting versus those that really are impacted by it,
Yeah.
it's different.
Absolutely. And it's, you know, it's interesting, sometimes the choices that get made for transportation projects. And then as a real-time user, I'm like, why did you make that choice? You know, what engineers decided that this was it? And a good example, I'm originally from Boston, and I had to live through the Big Dig, which was one of the largest public works projects ever. That's where they were basically taking a whole lot of traffic that was above ground. They built all these tunnels to try and divert it. But one of the things I never understood is they're like, well, we're making it for what the traffic is today. And I'm like, but wouldn't historical data tell you that we had what we called the Southeast Expressway, more commonly known as the Distress Way. And it was built to handle like 30,000 cars a day. And then it was handling like 250,000 cars a day. So I was like, all right, so if you're going to fix this, wouldn't you say, let's build it to future-proof, to anticipate that there will be more and more vehicles, and make it to try and fit not just today, but like 20 years from now? That didn't seem to be the thought. But again, I'm not a transportation expert, so I don't know what goes into it. And there may be a line that you got to look. This is all that we can do.
Then you bring up an interesting point with that, and that's one of the things that I like about the program that we offer, because in this process, the students have had an ongoing dialogue with those at the Transportation Authority to be able to actually make the game as dynamic as the situation calls for. And so not so much as trying to future-proof the actual engineering. If this game works in a way that allows you to get valuable data, then maybe you need to update the data for something that has changed. Because we're doing simulations, it's so much easier for us to just upload and give a new version.
Absolutely. Sit there and say, all right, all of a sudden there's, you know, stoplights have been changed to be only this long, and now there's 10% more cars or vehicles. I don't want to just say cars, but vehicles, there's just 10% more traffic. What does that do?
And that's exactly what they're able to simulate, which also goes back to your earlier question with like AI. They're able to actually incorporate those AI models as well into the simulation. So not just in helping them with the coding itself, but actually with the game's ability to think about different scenarios and situations, which is a really cool advancement, right? Because if not dating myself here, but
I've dated myself a lot, so don't worry about it, Anthony.
You play a game that involved a computer opponent or feature, and it was only as smart as what it was programmed to do in anticipation of what the player did, versus it being able to actually adjust and do things dynamically based on a scenario, and that being a factor in games really allow it to be much more intelligible interactions of what you choose to do and what it chooses to do as well.
And are these, I'm making this guess, but the models are using the past data to inform the decision, or, you know, the simulations today, so that you're not, as you said, back in, we'll call it serial games, it only you had a set number of things that could happen. Whereas with AI and stuff, there's the learning that goes on. Says, oh, I've got all this data, and I'm going to actually continuously analyze the new data I have to update
whatever's happening.
Whatever's happening.
And because the way things are going now, the games that are created are able to use real-time data. And so as much as it would be historical data is because it happened yesterday, versus what we may have had to re-upload new data or have it, now it's real time.
Right.
So.
And I'm guessing that the Contra Costa Transportation Authority is finding this to be very useful.
Well, right now we're just in development phase, but looking at the staff members that we are working with, you can see the excitement with the idea of students being able to say, just tell us what you would want. Take off all the limits of what you think it may be, because that becomes the challenge for the students, which for me makes it that much easier to get them through curriculum, because the challenge is real world.
Yeah.
So if you're talking to me about this game idea you have, and let's not talk about the limitations of the tech.
Yeah.
You just get it off your chest, like let it all out, like a good writer,
Yeah.
right? You'll put together this great book, and then when you're finished with it, you're like, huh, science fiction. But the point is
Yeah.
you would do that after you got it out, versus you being limited by what the scope or range may be. And so,
Absolutely. And do you think that some of your students may become transportation engineers or something just through the work they're doing? Like, ooh, this is really interesting. I'd like to pursue.
I think yes and no. And what I mean by that is, it's almost like when you are a web page developer. You might make a web page for a coffee shop. You didn't want to go in the field, but you stayed with them to be the webmaster and continue to update the page.
Sure.
I think a lot of the students that are working on these projects, one, it does open them up to the field of an understanding, but it also opens them up to how they can apply the skills that they currently have and are pursuing, because I do high school, so they're going to go off to college and get their degrees
Right.
in other areas, to areas that they didn't necessarily think before. So as a game designer or computer programmer, did I think that the Transit Authority was a potential employer?
Yep.
And that's where you have that difference now, so that they're
Definitely.
able to stay with the company, or I say company, but organization, try to become something, show their skills, and most importantly, and that's one of the biggest things I like to highlight about what these students do, is showcase how these things can actually merge together, because you would not think Transit Authority and game design as anything that would be any kind of a...
I will say absolutely. I would not have put those two together, but in your explaining it, it does really make sense. So just talking about you for a moment, Anthony, how did you get here? How did you get to helping students with, the Game Academy?
So I'm gonna go a little bit further back with myself as a whole. I went off to go do aerospace engineering as a major. So I graduated around the time of 2001. And there were events in the world at that time that kind of took aviation away.
One could say there's some
major.
historical
Something.
things that happened that had an effect.
But my wife suggested that I go into education at that time, while waiting for things to settle and everything else. I started off being a science teacher, but in being a science teacher, I was noticing the struggles of students with their mathematics. So then it was like, okay, I'm going to go into mathematics. And then in doing mathematics, it was like, but a lot of the things that we do in computer science are tied to the mathematics.
Yeah.
So for me, it became, well, where can I do the most in terms of merging what the students need to know and what they need to know it for, versus just the inline curriculum. And so the opportunity to do game design, programming, but then have a purpose for it. Now it's not just this side page of like, that was interesting, you took auto when I took game design.
Yeah.
It's now still career oriented, it's still skill based, so students are working with physics still and all their other core classes. So
And that's honestly really important from the psychology of learning. If we tend to engage with the things that we find interesting and we're curious about, but if as teachers you can't spark that curiosity, you can't foster that what's possible, right? Because technology, we'll talk about technology. It's because someone thought about, gee, it would be fun if this existed. How might I make this happen? Right? That's how everything has happened, because someone goes, be cool if we could do this.
And that's something that I'm seeing in working in industry, or trying to bring industry to classroom or classroom to industry, is the idea of maker spaces, where now it can be that idea exists somewhere in the region. And because there is a makerspace in that region, you can literally just go in there and just put your idea to prototype, whether that's 3D printing it or just working with someone on how to prototype it.
Right.
And now things can come, not necessarily to market, because it's not always about something being sold.
No, but it's
it's
the idea of I had this idea and now I have something tangible in some way, even if it's writing code, but saying now there's a program that I can run. You're right, you may not sell it, it may go no further than that, but that excitement of I had this idea and now I made it real. The same way that in art, you think of I did ceramics when I was in school. So the idea of I'd like to try and make this pot. I imagined it. I was actually able to then make it. Maybe it didn't look exactly like I thought.
Right.
But I was still able to create this thing out of material, and the same is true with programming. And obviously programming is really, really important because, well, everything everything around us has programs.
Some form or nature is connected, yeah, so definitely.
And here's just a kind of off-topic question, but so for all of the AI we see, is the backbone Unix, C++? Is it, because, you know, as fancy as the languages get, there are just some core languages that are just behind the scenes, they're the ones doing it. Do you have any idea what?
I think everyone has their own proprietary version of what it's running on or backbone, so I really couldn't.
You could say, okay, no, it's fair enough.
I could say it only to have someone come back and tell me that I was wrong. Like,
right.
That's what it would be.
Exactly. I'd like to ask my guests sometimes, of the concept of not yet, the things that we say, someday I'd like to, or whatever. But for you, what's one or two of your not yets?
Okay. A not yet for me that I'm actually working to have be a now.
Yeah.
Gets to what we're doing with these various events and showcases. And so we just did in April at the Contra Hilton, we did a Tech in Action event. And that purpose of that event was to allow students from anywhere to just come show whatever it is they may have made. And so my not yet is the current scope, with the current reach. Like, we really want to be open enough so that if you're homeschooled, you just like, but I made this. Come let someone see that. And so that's my not yet right now.
Absolutely, and that's a great one. And I remember you telling me about that event. Unfortunately, I was out of the country, so I couldn't come to it, but I did want to show up to it. Where, you know, if people are interested to find out where your next tech event is there someplace they can go to find it? Is it on the...
Oh, it's already up and running. We're going to do March 27th of 2027 at the Contra Hilton again. And in terms of where they can go right now we're looking at techinaction.lovable.app. So it's a lovable. You can just search Tech in Action now. We're pretty high up on the list there.
Oh, good.
But it's already up and ready to go. You have a year's notice to stay in the country.
Yes, I do. I do. Well, Anthony, I want to thank you so much for coming in. What a fascinating conversation, and I love what you're doing with the youth of Clayton Valley High.
Yeah, thank you, and I appreciate it.
Not a problem. I want to remind everyone that if you're ready to begin your epic journey, go to epicbegins.com. And as always, remember, epic choices lead to the epic life that you want.